Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on the 26th of June, 2025 T 0 hours 33 minutes and 43 seconds, 0.000Z. This paper, published just yesterday, introduces a new agent that reduces the execution cost of complex image editing tasks by nearly 50%. The paper is titled FaSTA, Fast Slow Toolpath Agent with Subroutine Mining for Efficient Multi-Turn Image Editing, and the way it achieves this efficiency is really clever. The authors propose a Neurosymbolic agent, which is a system that combines LLM planning with more structured rule-based reasoning. It learns from past successes to create efficient shortcuts for complex edits, saving significant time and resources. Also, the authors shared their implementation on GitHub, and it's quite comprehensive. You'll find the official codebase, scripts to run the agent, and even an interactive Jupyter Notebook demo that walks you through the entire process. It seems like everything you need to get started is right there. So this figure really gets to the heart of how FaSTA works. At the top, you see the subroutine mining. The system learns from past edits using an LLM to find successful tool sequences, which it saves as reusable shortcuts called subroutines. Building on that, the bottom half shows the adaptive fast-slow planning. For a new task, it first tries a fast plan using these learned subroutines. The result is then checked by a vision language model, which is an AI that understands both images and text. If the quality is good, it moves on. If not, it triggers a slower, more methodical A* search to find the optimal toolpath for that specific step. This table then gives us the hard numbers on how well that adaptive planning actually works. It shows the fallback statistics, basically how often the system has to switch from its fast plan to the slow one, and the results are pretty striking. The high-level path, which uses those learned subroutines, is successful 91% of the time. That means only 9% of subtasks require a fallback to the more intensive A* search. This high success rate is exactly why the agent is so efficient, as it avoids that costly search in the vast majority of cases. Building on that efficiency, this next figure gives us a qualitative comparison. It shows how FaSTA stacks up against the previous state-of-the-art, COSTA, and other agents on complex, multi-turn editing tasks, requests with several steps. And you can see that FaSTA produces results that are visually identical to COSTA, successfully changing signs, recoloring objects, and even replacing animals. But it does this in nearly half the time, just 28.7 seconds on average, compared to 53.8. This really drives home the point that the efficiency gains don't sacrifice final quality. And this chart really visualizes that trade-off with what's called a cost-quality Pareto frontier. A Pareto frontier essentially represents the set of best possible outcomes. Anything on that line means you can't improve quality without increasing cost, or vice versa. And as you can see, FaSTA results, connected by that dashed line, form a superior frontier. They're all clustered in the top left, meaning they deliver high quality for a much lower time cost, far outperforming COSTA and all the other baseline methods shown on the graph. So, to wrap things up, the key takeaway here is really about smart efficiency. For those complex multi-step image edits, this Neurosymbolic agent learns from its past successes. It creates reusable shortcuts, called subroutines, to handle common requests quickly. It only falls back on a more intensive A* search, which is a classic algorithm for finding the most efficient path when it faces a truly new or difficult problem. This adaptive strategy is what slashes the editing time by almost half, without a major hit to the final quality. That's all for this edition of the AI Research Roundup. Thanks for tuning in.